Good afternoon, ladies and gentlemen of Algebra Honors. Good to have everyone here today. We're going to pick up where we left off on Wednesday, which was with problem 4 here completed. Do you remember that? Because this is exactly from this class Wednesday. Or maybe you slept a couple times since then. It happens. So what we're going to do is, this is a factored form. We're going to go on to problem 5, which starts with what we call using a quadratic regression feature on your calculator. You have your calculator out? There, everybody? Yeah. Connor, you got your calculator? Okay. So we're going to actually use our calculator most of today to model quadratic, to fit model quadratic data. And if you recall, on Wednesday what we did is we were just looking at the graph and picking out a vertex and then using a vertex form to fit, right? Pick a vertex and one other point. And we're going to have a chance to compare a little bit with what we did on Wednesday. But now what we're going to do is put this in our calculator. And does anybody know how to do that? Jay's nodding his head no. Do you know how to do this? Yeah, you go to Stat Edit. 2, 3, 5, 7, 8, 9. So here, you go to Stat Edit. So here we get to our calculator. Let me see if I can get this up here. Okay, Stat Edit. So we go over here to 2, 3. What is it? 2, 3.
Where is
5, 7, 8, 9, right? 7, 8, 9. And then I have 2 remaining points, so I'll just hit delete twice and get rid of those, okay? And now we go ahead and put the requisite output values, which are 2, 1, 1, 2, right? 2, 1, 1, 2, 4, 7. Does that look right?
Yeah.
Delete, delete. So does everybody have this in their calculator? Anybody not have it?
Not yet.
Yeah, so just go ahead. I want us to be on pace here. Okay. And now we look at our graph. And just look at our graph. I want to dimensionalize our viewing window in our calculator to match up with what we have here. And so now I'm going here and I go to window and I'm going to go from 0 to 10 by ones, and y is 0 to 10. Where did I get that 0 to 10? I got it right from the graph here. And I have grid lines turned on, so this y scale means I'm going to have horizontal line 1 apart. And over here the x scale means I have a vertical line 1 apart.
How do you turn on the grid line?
Well, the thing about it is, for grid line, what you do is this. You go to Second, Format. This is where you do it. Now, you guys who have a regular TI-84 will not have something that looks exactly the same. You'll have, I suggest you use like grid dot, so you see the little dots. The problem with the TI-84 is it doesn't have enough resolution to offer the faint lines like mine has up here. Were you able to use the dots for that, everybody? Okay. Also, another problem with dots is that if you take, if you have the dots and you don't, and you get the dots too much together, it'll make your whole screen black. So you got to just watch out for the dimensions on that too. because you'll black out all the resolution on your calculator view screen. Yeah, but it looks like that. So you did it with the dots, right? So that looks pretty good. So anyway, what happens is I look over here, and I'm going to erase these functions I had from 7th period. If I have plot 1 turned on, I'm going to graph and see if everything is there. Does everything look good there? Yeah. So now I'm going to go ahead and determine the function using quadratic regression. And where do I go for that? Stat, calc, 5. So 5, and enter, 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 one last enter. So this is what you get. And for this, what this really amounts to is that we have 0.296x squared minus 2.604. I'm going to call it 2.604. And then plus 6.143. Okay? So A equals 0.296. How many do I have here? Other classes. Where is that? Here it is. Got it right here. So 0.296. B is equal to negative 2.604. And C is equal to 6.143. Now, do you notice I went to 3 decimal places here on this? Was it totally necessary for me to go to 3 decimal places? No. But I'm trying to get you in the habit of 3 decimal places where you can, and the reason I want you to do that is if you happen to take like a AP test at some point for calculus, this would be a standard. 3 decimal places is kind of the standard. So it really depends what you look for. So now we have 0.296x squared, so we go over here. So 0.296x squared, right? And then we have minus 2.604x and then we have finally plus 6.143. And that would be it, right? Graph. Think it's going to match pretty well?
Yes.
It'll match really well, and this is going to be similar to one we did in I think it was Tuesday that we actually worked out a problem like this. I remember Riley Bailey showing me this one. I think it was A was 17 over 50 and H was 4 and K was 0.5. Does that ring a bell to anybody? And part of the reason it's fresh on my mind is from 7th period class. So 17 over 50, it's either 17 over 50 or 13 over 50. We'll see if it's wrong. Then we have x minus 4 squared plus 0.5. See how it matches.
I think it's 13 because I have 6.5 over 25 and you multiply them by 2.
So it'll be 13 instead?
Yeah.
Okay, yeah. Yeah, so I misremembered it a little bit. Thank you. So let's try this. It'll probably match even better. That's going to be the red one. Okay, so now we have, which one matches better, the blue one or the red one?
Blue one.
Blue one matches better. Okay, what your calculator does, but is the red one really bad? No, it's not, because it matches pretty well. Now, do you know how the calculator finds the blue one? Okay, the blue one is found by using what they call the least squares method. And so what they do is they find the variance between, and they go ahead and find the curve that would create the least amount of mathematically determined variance by squares. It's called the least squares method. When you go into statistics, some of you will at some point, or like I did summer before last, linear algebra, you'll learn about using that kind of method for that. So that's all it is. So the calculator does it for you, and coincidentally it gives you a really good, accurate rendering. So what I want you to do is look at number 6 and just work out number 6, and I'm going to choose randomly somebody to help me with number 6. How's that? So just work on number 6. Yeah, so just relax about that. Any question about entering values or all that? Everybody's pretty good with that? Okay. Let's go to our wheel. Here we'll choose a victim here. I'll shuffle this up a few times. All right, let's go see who's going to help us with it. It's going to be Peyton. I know it's going to be Peyton.
Okay, so the second.
It's gonna be good.
It'll be Marcus. Okay. It'll be Marcus. Seems to land on Peyton a lot. Oh, really? Okay. All right, Marcus. How'd you do this one?
You go into stat edit and come on to the chart.
So stat edit, he says, and put them all here. So what's going over here?
1 through 9.
2. So it's going to be 2, 3, 4. 2, 3, 4, right? 2,
3, 4,
3,
6, 7, 8, 9.
4, 6, 7, 8, 9. Like that. Is that right?
Where's your 1?
You don't know that.
You missed the 1.
Was there a 1?
Yeah.
So it's 1, 2, 3, 4, 6, 7, 8, 9, right?
Yeah.
So 1, 2, 3, 4, 6, 7, 8,
9.
9. So is that all of them?
Yeah.
Has anybody tried to
Oh,
do,
gee, I think I did it wrong.
Oh, it's because it's, oh wait, y'all did something wrong.
so now we have, what is this gonna be, Marcus?
How did I
Negative,
go to table?
negative, or it's 1, right?
I forgot that.
Is that right, Marcus?
It's negative 2, negative 3, negative 5, 2 negative 4s,
Okay, negative 4, negative 4.
negative 2, and 3.
3, okay. So that is them, right? Let's go take a look at the graph, see if we match here. Does that match? No, it doesn't. So the graph's not matching, right? What do we have to do to get it to match?
You go into Windows, but I don't know what to change into.
Okay, let's just look at the window, right? What's going to be a good window here? I'm
Zero.
thinking, yeah, what'd you say, Kim?
For the y, I did negative 5.
Negative 5? And what else? What goes up here?
I did 5. But
5? Negative 5 to 5. Let's see if the points fit here. Now so this is a good window except this last one right here. So, I mean the one very, very bottom. So the only thing, this could work, but the only thing I would suggest maybe instead of going negative 5, go to negative 6. So it just gets all the points in there a little better, right? And what happens when you get familiar with the way these things work, you eventually learn how to go outside the edges a little bit. All right, Marcus, go ahead. What next?
Then you go to y equals, and go to problem 1.
Okay, that's it.
I'm kind
Okay,
of lost at this point.
so is that how far you got? Okay, so really, he's done the hard work. What does he have to do now that's easy?
What did you notice?
the now.
Stat,
Stack out 5.
count 5,
Yes, I knew it.
and enter. Now, one thing you got to watch for is this X list and Y list. Make sure these are the same things that you entered. Like if you go to stat edit, you'll see L1 at the top of the first column, L2 at the top of the second column. Then we press enter, we get this, right? Is that what you got, Marcus? Okay. And what do we do with these values here now?
You write them out and you go through even decimal.
Yeah, so let's do that. So we got 0.430, right? 0.430 x squared. Okay, and then what?
It's
Negative. What point?
So minus 186, is it? Negative 4.186. Oops. Well, minus 4.186. And what's the last one?
4.946.
Is it plus or minus?
Plus
4.946?
94. Yeah.
this graph, see how that looks like. Does that fit pretty well? Yeah. Okay. Any questions on that? Okay, what I want you to do now is I want you to go to number 7 and work that out. The town is holding annual music festival 6 months from, and so forth. Did number 7?
Where'd you?
Good job. Anybody need help with number 7? Helping each other. Abigail, you're doing okay on this? Okay, she's doing. Okay, now I want to shuffle this up a little bit here. Here we go. Peyton. It's going to be Abigail. I know Abigail's ready because we were working on that, right? Abigail, you got chosen here. Good job.
Okay.
So we go to do the calculator here.
Yeah, the stat.
So stat, edit. So enter the values here. Let me see here, and just, was it, you got was it 25?
25, 30, 35, 40, 45, 50,
35, 40, 45, 50, 55, 60, is that all of them?
Yeah. And then for this 1, 2, 17,
20,
30, 34,
is it 20, 34? Yeah, 20, right?
30. It's 28.
Or 28?
28 after 17.
28, okay.
And then 30, 34, 26,
26,
26, 21, 7.
21, 7.
There's only 126.
Only 126?
Yeah, 1.
What's going to happen is, if I forget to do that, I'm going to run into a problem, but I can just delete that, and now that's good, right? Is that right, Abigail?
Yeah.
Okay, what next? So stat, calc, 5,
Calculate.
enter. So is this what you got? There we go. Okay, and if we put that in here, let's see, hang on a second. And so would you get negative
Negative
What?
0.090.
7? Seven, okay. X squared
7.836.
plus 7.836
And then minus.
X.
And then the last one was negative 136.684.
Okay, and we graph, we should see,
I don't know.
I'm not seeing anything. What's wrong?
Your window.
The window.
The window, right? So let's get our window set up here.
Go down under.
So window go from 0 to, I think it's 0 to 60, is it, or 0 to 70?
0 to 64.
Yeah, I rounded it.
And
And we're gonna scale by 5s. Okay, what about Y? We're going from
Y was 0 to 36.
0 to 36, we go to 0 to 40 by 4s.
Under 40.
Is it negative 40?
Huh?
Or is that
No,
right?
No.
Is that right?
Yeah.
Okay, there it is. Does that match pretty well? Yeah. Okay, what I want you to do, kind of as an extension of this, I appreciate it, Abigail, I want you to go ahead and take this right here. Remember where we said find the vertex? In fact, that it's actually here, part A. Find an approximate function model for the data by estimating the coordinates of the vertex and using one other point. Then sketch your graph. So I want you to do that on part A, and I'm going to choose somebody randomly for part A, okay? So find a vertex and one other point and try to do what we did on Wednesday.
Do you see where he's going back to?
Where did mine like
What we did.
to find the vertex?
I just don't know the vertex.
Oh, yeah, I was confused
Should
on
we
the
do the
second.
vertex?
Are all the graphs the same graph?
Yeah, what would you choose for a vertex here for this?
And
40,
then,
36?
Do you do 45
Or
or
you
do
said
you do
45.
40, 30? Well, I'm using 40, 30.
Yeah, so Kim, you say you're using 40,
No, that was Jaden.
She took my answer. I told her.
You could use that as a vertex, right? Or this up here. I think 7th period, they use this one up here. Or do you have to use one of these that's given already? No, you could make one up, say, well, I think it looks like it might be over here a little bit. To me, if I could, I maybe would use just one of those points. Where did you use that? So Abigail said she used 43, 31. Well, if you look at 43, it's right here. And 31 is right here. So 43, 31 is right there, right? That would be a good one too. So use whatever one you want. I'm going to call on somebody else.
I got confused.
I'm using
Do you know what to do here?
I got
40,
confused, so I'm not sure.
What vertex did you pick?
I think that one on the right at the very bottom right.
This one here?
the vertex you said?
Oh, for your second point.
Yeah.
Yeah, that's another thing, because Connor brings up a good point, is after you estimate a vertex, whether it's the one Jaden estimated or Abigail, whatever, the next important thing is to check your second point, right? And to me, Connor, I would choose this one here or this one over here, either one, right? And We'll just see what happens. And we're going to compare it with the quadratic regression graph too. See what that looks like. Okay. Let's pick somebody here. I'm gonna shuffle a couple times.
Peyton's, it shouldn't be for today.
So it's gonna be Peyton.
Yeah, it's gonna be Peyton.
You're off.
No, it should not be.
Peyton, Peyton.
Peyton.
Peyton, you want me to spin again?
No.
I'll spin again.
No.
The thing is picked on Peyton a lot. Peyton,
If it lands on me,
no, that's fine because Peyton has been picked a lot, and I was kind of joking about him there. So Bryce,
Go Bryce.
all right, Bryce.
I
Bryce.
didn't get that very far.
Kim,
Okay, but let's just show where you got. What did you
I
pick?
used 4530,
So 4530 is what Bryce uses here.
then I used that, I guess it's 25.2.
And so 25.2, okay. So use this point here.
Yes.
Is it 25.2? Okay, 25.2. Okay, let's just go ahead with these. That's good. All right. Let's see where 45.30 is. 45.30, about right here. Okay, so that's a very interesting one. Why did you pick that one, Bryce?
Because that one's really high and that one was close to it, so I knew it was going to be something.
Okay, now what Bryce is doing is he's consciously saying that this one up here looks out of place, right? And so he's just going to, in effect, he's going to sort of minimize the impact of this one right on top of it. And is that a good decision? Yeah, I don't know. We'll see how it matches. We know it's not going to raise it as high as this one here, but it'll still fit a lot of the points probably pretty well. Let's go ahead, Bryce. What do we got? We got f of x equals
A x minus 45 squared plus 30. That's where I am.
okay, good.
That's
So you got there? So let's just go ahead and finish the rest of it. So we're using this 25.2, right?
Yeah.
So 2 is equal to A times 25 minus 45, is that right?
Yep.
Squared plus 30. And then what's 25 minus 45?
20
20, right?
or negative 20 actually.
So it's going to be 2 equals 400A, right?
Yeah.
Plus 30. And so we subtract, we get 400A equals negative.
20. No. I don't know.
negative 28, right? Does that look right? Does that look right? So A is equal to negative 28 over 400. And I think that simplifies to, like, that's going to be like 7.
14 over 2 over.
Is that it? Is that it, Ben? Negative 7 over 100? Yeah. You see how I've got that? Divided by 4 here, divided by 4 here. All right, let's go here, Bryce. So we got f of x equals negative 7/100, and we have x minus 45 squared plus 30. Is that right?
Yep.
Okay, let's take a look at it. So negative 7/100ths, 7/100ths. And we're gonna have x minus, what was it, 45? Squared plus 30. Let's see what this baby looks like. Okay? So you can kind of see what the estimating does, right? Kind of shifted over to the right a little bit. Which one fits the points better?
First one.
Yeah, the one fits better, but then if you take that out of there, if you had to do it over again, would you re-choose a vertex?
Oh, yeah, probably.
Probably, yeah. But is this really a wrong answer here?
Yes.
No, it's not. It's not really. There's not a wrong answer.
You still the wrong vertex.
Okay, so anyway, you should be able to, I just want you to turn in that paper as is.